Hello everybody, in this video I will explain to you.
Let's talk about time shift property in Fourier transform. If the Fourier transform of Vt is V omega, then the Fourier transform of shifted Vt, which is Vt minus d naught, is V omega multiplied with exponential functions, which is e to the power of minus j omega d naught. So this is the time shift property in Fourier transform. A time shift in time domain will result in a multiplication of exponential functions in frequency domain. Let's consider this example. The figure shows a signal Vt, which is actually a shifted rectangular signal. Then the question is, find V omega, which is the Fourier transform of the Vt signal. The solution of this problem will begins with a reference signal, where we have to choose a reference signal, and in this case the signal xt is chosen as the reference signal. The parameters of xt are given as follows. V naught is the non-zero amplitude, and these non-zero amplitudes begin from t equal to minus 1 over 2 to t equal to 1 over 2. Then the Fourier transform of xt is x omega, and based on the signal xt, x omega is equal to v naught sinc omega over 2, and this x omega is obtained based on the Fourier transform pairs. The rectangular signal is actually one of the signals that can be found in the Fourier transform pairs. All the signals in the Fourier transform pairs can be seen in the previous video. So it is possible to straight away find the Fourier transform of the rectangular signal by looking at the parameters of the signal itself. So how to relate the Vt with st? So we can relate these two signal Vt equal to xt minus tau Then based on the time shift property, V omega is V naught sin omega over 2 multiplied with e to the power of minus j omega tau. Basically, we multiply x omega with e to the power of minus j omega tau. This is the next example. Find the Fourier transform of Vt. In this case, the signal of Vt is different than the previous signal in the first example. Given Vt equal to V1t plus V2t, then V omega should be equal to V1 omega plus V2 omega. This is valid according to the linearity property of Fourier transform. Let's start with V1t. How to find the V1 omega? Based on the signal given in the question, we have to establish a reference signal like this. We call it xt. Note that the parameter values of the xt is chosen such that the signal operation involved would be minimum. Based on the reference signal xt with its parameter values, then based on the Fourier transform pairs, we can easily find the x omega, which is x omega equal to tau sin omega tau over 2, and we can relate the signal V1t with xt. In this case, V1t is actually the shifted version of xt, where xt is shifted to the left by tau over 2 unit of time. Again, based on the time shift property in Fourier transform, we know x omega, and we also know V1t equal to xt plus tau over 2 in time domain. Then V1 omega, the Fourier transform of V1t, is the multiplication of x omega with exponent functions tau sin omega tau over 2 multiplied with e to the power of j omega tau over 2. So this is the equation for V1 omega. If we apply similar steps to the V2t, Since we already know the Fourier transform of v1t and v2t, then the v omega is basically the summation of v1 omega with v2 omega. So v omega equal to tau sin omega tau over 2 exponent j omega tau over 2 minus tau sin omega tau over 2 e to the power of minus j omega tau over 2.
I will see you in the next video.